Today, we'll be solving LeetCode 25, reverse nodes in K-group. This is a hard linked list problem and a very common interview question. The task is to take a linked list and reverse its nodes in groups of size k. If the total number of nodes is not a multiple of k, then the last remaining nodes at the end should not be reversed and should stay as they are. For example, if k equals 3, we reverse the nodes in chunks of 3. If there are 2 nodes left at the end, we just leave them in the same order. The important part is that we are not allowed to change the values inside the nodes, we must actually rearrange the nodes themselves by manipulating their pointers. Now, let's talk about how to solve this. The main idea is to process the linked list in groups of size k. For each group, we reverse the nodes, then connect that reversed group back into the rest of the list. To make the code cleaner, we will use a dummy node at the very start of the list. This dummy node points to the head, and it helps us handle edge cases where the head itself might get reversed. We will also need a helper function that can find the kth node from a given starting point. This will allow us to know whether there are enough nodes to form another group. If there are not enough nodes left, we stop and leave the rest of the list unchanged. Now, let's carefully explain the code in English step by step. We start by defining a function called reverse k-group that takes 2 inputs, the head of the linked list and the integer k. Inside this function, we first create a dummy node with value 0. Then we connect dummy's next pointer to the head of the list. This dummy node is very helpful, because it makes it easier to reconnect groups later on, especially when the head itself gets reversed. Next, we create a variable called groupPrevious, and we set it equal to dummy. This variable will always point to the node that comes right before the group we are about to reverse. Then we enter a loop that keeps running as long as there are enough nodes left to form a group of size k. Inside this loop, the first thing we do is use the helper function to get the kth node starting from groupPrevious. If the helper function returns nothing, that means there are not enough nodes left for another group, so we break out of the loop. If the helper function finds the kth node, we call this node groupEnd. We then save the node that comes right after groupEnd into a variable called groupNext. This is important because after we reverse the current group, we will need to reconnect it back to the rest of the list. Now comes the reversal part. We set 2 pointers, one called previous, which starts as groupNext, and one called current, which starts as the first node of the group. Then we use a loop while current is not equal to groupNext. Inside this loop, we first save the next node of current into a temporary variable so that we do not lose track of it. Then we change current's next pointer to point back to previous, effectively reversing the link. After that, we move previous forward to current, and current forward to the temporary node. We keep repeating this until the whole group is reversed. At this point, the group has been reversed. The variable previous now points to the start of the reversed group, and groupPrevious.next should connect to it. So we connect groupPrevious.next to the kth node, which is now the start of the reversed section. Then we move groupPrevious forward to the node that used to be the first node of the group, because that node is now at the end of the reversed group. We then continue the outer loop for the next group. When we eventually run out of nodes to form a full group, we stop the loop and return dummy.next, which is the new head of the modified linked list. The helper function called getKth is also simple. It takes 2 inputs, a node called current and the integer k. While current is not null and k is greater than 0, we move current 1 step forward and reduce k by 1. If we reach the end and k is still greater than 0, that means there are not enough nodes. Otherwise, we return the node that we landed on. The time complexity of this solution is O of n, since each node is visited and reversed exactly once. The space complexity is O of 1, since we only use a few pointer variables and no extra data structures. This problem teaches us 2 key linked list patterns, using dummy nodes to simplify pointer operations, and reversing a sublist by carefully managing next pointers. These 2 ideas appear in many advanced linked list questions. And that's how you solve LeetCode 25, reverse nodes in K-group. Thank you for watching and let's keep learning.